All right, we're going to go through things as quickly as we can on each one of these SWYKs, but I am probably going to record maybe like an extra optional video that you can use as a resource with some practice problems in it. Anyway, we're talking week 6, set 1, SWYK 1. Let's take a look at some notes here. I've drawn out, or I've listed out a basic quadratic function, y equals x squared. That's about as simple as it gets. That's a quadratic function, and I hope that my cat does not claw my leg because it doesn't feel that great. And she thinks she can play right now, and I can't. Anyway, so we've got a parabola, and you'll notice that I made a table. This is not something you need to do every time. You can, and so we look for things like the middle of the parabola. We actually have a name for that. We call that the vertex. It's the place where it changes directions, just like on an absolute value function. So the vertex being the middle, and then of course since I made a table, I picked a couple x's on one side and a couple x's on another. I want to show you a method of graphing called the 1a, 3a, 5a method of graphing. And typically we don't even get to the 5a because it jumps too far off the graph. A lot of times we just get 1a and 3a. But yes, you could do 7a, 9a, 11a, and it could continue on forever and ever and ever, but we don't want to do that. Anyway, so let me zoom in here a little bit and show you what I mean. Since the a value in our graph was clearly a positive 1, that's the multiplier on the squared term, just like you would have at an absolute value function. We have, let me pick a different color here, purple. Yeah, purple's already been used. I need to move my face. There we go. All right, now, starting at the origin, if you move 1 unit to the right, then you follow A to find the next point. Since this is a positive number, that means I would move up 1 unit. Okay, so I found another dot. The next thing I do is I go 1 unit to the right again, but instead of going up 1A this time, I go up 3A, which in this case is 3 units. So we went 1 unit up the first time, 3 units up the second time. Then you'll notice that I copied these points to the other side across the middle. Now the middle actually has a name. The line that goes down the middle is called the axis of symmetry. Axis of symmetry. Now I always abbreviate that with, let's get it written out first. You'll always see me abbreviate that with AOS. Now, remember, it's a vertical line. Every vertical line looks like x equals a number. In our case, it would be x equals 0. Okay? So anyway, that's the basics of graphing, 1a, 3a, 5a. We find the vertex, and then we use the 1a, 3a, 5a method to graph and find other points, and then we graph the ones on the opposite side of the axis of symmetry. Okay, so in question 2, you can see that we start out with a basic parabola, but this time it's been shifted down 4 units, okay? So just as a review to you, so you can kind of understand, the a value controls whether it opens up or down, just like in an absolute value function. A is positive, it opens up. A is negative, it opens down. Then we have our vertex. This is called the vertex form, which we'll get into more and more as we continue in this particular. The reason it's called the vertex form is because you see the vertex. I know, it's kind of an obvious thing, but just like with absolute value, it looks backwards on the inside before you square it. Absolute value is obviously inside the absolute value bars. And exactly like what you think on the outside. Thank you, cat. She's adding to my video sound effects. Anyway, so in this particular case, oh my goodness. In this particular case, you can see that nothing has been added or subtracted to the x before it was squared. There is a shift on the outside of down 4 units. So there's my vertex, 0, negative 4. Let's take a look at the picture. We also know that the a value is a 1, right? The a value is a 1. So in terms of graphing with the whole 1a, 3a, and 5a method of graphing, we have 1 times 3 times and 5 times. Why can't I draw a 5? Seriously. All right, so you can see in my picture, I went over 1, and then I used the A value to find another point. Over 1, used the A value to find another point. So we had 1A, 3A, and then 5A. We did have enough room for, why can't I draw a 5? Seriously. And then we just copied the points to the other side. We have that nice axis of symmetry of x equals 0 right down the middle. And so you could just copy the points to the other side and then draw the shape. We will be asking you for basic any kind of details that you can give about what happened in the graph. And in this case, it was just merely translated or shifted down 4 units. There was no reflecting. Reflecting across the x-axis, that would actually cause the graph to go upside down like that, and we didn't have anything like that. Okay, that's enough for this video. I will create another one that has a little bit more, some more detail about question 1. And of course, we'll talk to you about question 3 as well. Okay, briefly, I should add, when you see something more complicated like this, the things that you need to worry about are finding the vertex, taking the A value, understanding what 1A, 3A, 5A are, and then going and finding that vertex, and then using it. 1 to the right, and then using your -3, 1 to the right, using your 3A, and of course 5A would jump off the graph. Okay, just thought I'd let you know. Yeah, I'll add more in the separate video.